this video we're going to focus on learning the process and the steps it takes to divide polynomials. What you need to be thinking about is back when you did long division, you probably did that back like 4th and 5th grade. So I need you to kind of go back through and think about those steps in order to divide with polynomials, okay? Because the steps are really the same. We are simply using more complex mathematics here. So again, dividing polynomials, we focus on the long division steps. So let's start with a couple of polynomials here. We're going to divide k to the third minus k squared minus k minus 2. We're going to divide that polynomial by k minus 2. All right, so a couple of things I want to point out before we actually start this process is this is a polynomial. It has a degree of 3, okay? And it's being divided by a linear polynomial, okay? So what we're going to be focusing on is simply dividing these polynomials with higher degrees by linear rules, linear polynomials. Okay, so we're going to set this up using what I call the hut, okay, the division hut. So I'm going to draw the hut here, and this value goes on the inside, so k to the third minus k squared minus k minus 2 all goes underneath the hut, and then the k minus 2 goes on the outside. All right, so don't let the k minus 2 freak you out yet, okay? Usually you're used to dividing by one value and whatever. Well, that's what we're going to be doing. When you do long division with your polynomials, you simply focus on the division part with that variable, the very first variable here. Okay, so we're going to go through and we're going to start by saying, what is k to the third divided by k? All right, so if you need a little bit of refresher here, set it up to the side, k to the third over k. Well, again, this is just an exponent's property. 3, remember you subtract your exponents. 3 minus 1 is going to give us k squared. So k to the third divided by k is k squared. Okay? So now what I'm going to do is I'm going to multiply, because that's our next step in long division. So I'm going to say k squared times k, which is k to the third. Then I'm going to I have to multiply by this minus 2. That's where this minus 2 comes in. So I'm going to do k squared times minus 2, or negative 2, and that's going to give me minus 2k squared. All right, so if you think about, again, that long division process, you have to subtract what comes next, okay? Well, when you subtract a polynomial, remember the trick I showed you. You want to change it to addition and then change your signs. So k to the third plus negative k to the third is going to give you 0. Negative k squared plus 2k squared should give us a positive 1k squared. Okay? Next step, bring down the next value, and we repeat the process. Okay, so k squared divided by k is going to equal k. All right, so I'm going to put a plus k up on top, and now I'd repeat the multiplication. K times k is k squared. K times negative 2 is negative 2k. Again, we do our subtraction. All right, so let me change colors up here for you. So remember, again, I like to add, change it to addition, and then change your signs. Okay, k squared plus negative k squared again is 0. Negative k plus 2k should give us 1k. Again, next step, bring down the next term. Repeat the process. K divided by k is 1. 1 times k is k. 1 times negative 2 is minus 2. subtract, change our signs. K plus negative k is 0. Negative 2 plus 2 is 0. So we don't have a remainder. So the solution to k to the third minus k squared minus k minus 2, there's a lot of k's there, okay, divided by k minus 2 leaves us with k squared plus k plus 1. So this is our solution. Yay! That wasn't too bad, was it? Now I'm going to do another one. And let's see what happens. We'll use a different variable in this one. We'll use n's. All right, so let's say we have n to the fourth plus 9n to the third plus 14n squared plus 50n plus 9 divided by n plus 8. Okay, so again, this goes on the inside of the division hut, this goes on the outside. Okay, all right, so let's jump in. Remember, all we divide by is this first term. So n to the fourth divided by n is going to give us n to the third. N to the third times n to the fourth. N to the third times your 8 is plus 8n to the third. Subtract. Again, I like to change the signs. N to the fourth plus negative n to the fourth is 0. 9n to the third plus negative 8n to the third is going to give us 1n to the third. Bring down our next term. Repeat the process. Okay? N to the third divided by n is n squared. N squared times n to the third, n squared times 8, 8n squared. Subtract. Change your signs. You see how repetitive this is? Okay, so as long as you repeat those steps of long division, you're going to be fine. N to the third minus n to the third is 0. 14n squared plus negative 8n squared is going to be 6n squared. Bring down the next one. And here we go. 6n squared divided by n is 6n. 6n times n is 6n squared. 6n times 8 is 48. N, subtract, what color? Let's see, here we go. Change your signs. That becomes 0. 50n plus negative 48n is 2n. Bring it down. (2n) divided by n is 2. Oh, I almost said a wrong thing there. 2 times n is 2n. 2 times 8 is 16. Subtract. Change our signs. 2n plus negative 2n again is 0. 9 plus negative 16 is negative 7. All right, so this is a little different from the last problem. This time we have a remainder of negative 7. Now I know it's probably been a long time since you've dealt with remainders, and that's okay, but we're bringing those back when you divide by polynomials. It is okay to get a remainder. It is actually significant and has meaning, but remainders will happen as you continue to divide polynomials. All right, we'll continue this conversation later.